Hi everyone, I am Chloe Hartung. So I'll start off with some background about myself. I teach Earth and Space Science at Penn Manor High School. I love earth science, I like hiking, and I think volcanoes are fascinating, astronomy is fascinating. I absolutely love it. I also, besides hiking, I like yoga and cooking, and my favorite cartoon character is Tommy Pickles. So my operational definition of STEM is that STEM is a collaborative method used to give students experience using science, technology, engineering, and math in an effort to help them understand how these disciplines work together in the world. And I liked this image that was shown in Capture 2 of the Vasquez book. I felt like it really helped individual fields really work together. One activity that I do in my classroom that incorporates STEM is during our earthquakes unit. I have some homemade shake tables in my classroom. So we talk about how skyscrapers need to be built so that they can withstand earthquakes. So at the end of our earthquakes unit, I have students research how skyscrapers are built, what are the protocols, what are some of the things that engineers need to be considerate of, the materials and things like that. After their research, I have them develop a plan. So they have a list of different materials that they could possibly use. They also need to decide on the size of the skyscraper, and the materials are each worth different amounts, so they need to be mindful of the cost of those materials as well. After their plan is finalized, then they can build their skyscraper. Once it's built, they can test it on those shake tables, and there's a reflection piece after. What worked well, what didn't work, why did you choose the materials that you did, those types of questions. So these are some of the different STEM practices that I think are incorporated in that earthquakes and skyscrapers lab activity. They are definitely asking questions, but they are not coming up with a problem. I'm presenting the problem to them. So they are figuring out, how do we solve this problem? How do we build a skyscraper that can withstand an earthquake? So they create their own investigation. They research on their own, and they figure that out for themselves. They also use different tools, create a model, they test that model, and they obtain data from their experiment, and they discuss why it was successful or why it was not. I think that STEM education is vital to our society. It's definitely something that is going to continue to grow as we grow as a society. So I tell my students, no matter what job you end up doing, you are solving a problem. Even if you have a job right now, maybe you work at McDonald's, your problem is the people need food and you need to solve that problem. Something as simple as that. So no matter what it is you end up doing, you are going to need to know how to solve problems. And if you just learn science, if you just want to be a scientist or just work in technology or engineering or mathematics, you need to know how the other three work in order to be successful in that field. They could not learn just one and not use the other three. So using them all together in a way that reflects how they're used in the real world, I think is very important for our students. Lastly, if you are literate in science and math, that's great. That's how you can solve problems, but you cannot be engineering or technologically literate without that science and math piece. So it's just one other way that they all work together. So some of my goals for this course, I think that when we talk about combining STEM into a science class, people have a tendency to choose physics. And I think that's fair because it's an easy connection, but I really want to learn how to better incorporate STEM practices into earth science. I think that's vital for us, and that's the class that I teach. So that's why I think that's important as well. I also want to get better at communicating to my students, like, hey, we're doing this earthquake collab, and here are all of these other connections. This is how it connects to the real world. I want to be able to let them know that this is why we're doing this and how it's being applied in that lesson. Lastly, I have this image which I got from a book called The Case for STEM Education: Challenges and Opportunities. I think that this is what STEM looks like in my classroom right now. It doesn't look like that gear where all four are working together. Right now, science is the main focus, and occasionally, if I can figure out a way, I've got technology, engineering, and math working inside that science piece, but science is still our main focus. So I want to be able to better integrate those other three disciplines into my science class.